Welcome back, everybody. We are proud to have Joey Shea with us. Joey is the manager of mission activation here at Interface. He has a great background in environmental and advocacy, nonprofit worlds. And so he brings a really unique perspective and energy level, I might add, to our mission activation and how we communicate and educate our customers and company we keep with what we're doing and how it affects the world. So with that, Joe, I'm going to turn it over to you, and then I will pop back in for Q&A later on.
Thanks, LC. I hear great things about how the week has gone. Thank you all for letting me be part of it. And thank you for, especially those of you that are back from last year. We're really glad to have kind of a returning crew. I think I met a couple of you last year. We'll talk about why carbon is kind of the title of the talk, but I want to just mention really quickly. I hear that a lot of this content has been pretty boss lady feminism vibes, which I love, and I just want to say I'm sorry that we have to take an interlude and hear from me, but I'm really standing in for the Lisa Conway, who is really a leader in this space. And I want to also acknowledge that I think in my experience in sustainability in general, but even more specifically when it comes to climate and when it comes to embodied carbon in the built environment, many of the leading voices, whether it's academic or intellectual, or whether it's kind of activation, or even whether it's business, are really women, and that's awesome and it's important. So again, thank you for letting me be part of this. So why carbon revisited? This is what we're going to chat about today, and I actually want to start by really just kind of answering the question. So when we say why carbon, to be honest, the short answer is it's a health conversation. It's a conversation about our quality of life, about the health of our communities and ourselves and our loved ones now, today. So this is a slide from the CDC that really helps us share and explain why climate change is an important conversation to have in the context of public health right now. So the CDC and the WHO and other leading health organizations agree that climate change actually poses the greatest threat to public health in the 21st century. And the reason for that is the American military uses the term threat multiplier to describe climate change, meaning it is a destabilizing force that just makes our vulnerable populations more vulnerable and challenges us to deal with more uncertainty, more change than our systems are used to being able to handle. So to kind of explain this slide and why we think it's a really useful and powerful way to explain this connection, this internal wheel here, rising sea levels, increased CO2 levels, these are the things that, especially in the US, we typically hear presented or shared in terms of the media when it comes to climate change. And there's good reasons for that. These are big scientific trends that really make a big difference and are changing our world. But the problem with them is that they are pretty significantly divorced from most people's personal experience, right? I do not feel a change in the parts per million in the atmosphere of CO2. What I do feel is more frequent and worse heat waves. So what this internal wheel does, which is the changes to the kind of macro level environment, is it drives the things in this second wheel. Things like extreme heat, worse weather, worse air pollution, changes in water quality. And what that means is that it's actually having local effects on our neighbors, on our communities nearby. For example, obviously the whole West Coast is basically still on fire, right? And a couple of weeks ago, we had some of the worst air quality in the world, not just within the US, but actually up in Vancouver, Canada, for example, because as it turns out, climate disasters don't really care about the lines that we draw on maps. So if we have issues in California that are causing a whole lot of smoke from wildfires, that's actually going to just travel up the coast and sit over Vancouver, for example. These are the things that we typically do not do a good enough job of tying directly to those same drivers of climate change. Another one, which is kind of air pollution related, I live in Atlanta. That's where I'm presenting to you from. Atlanta does have a lot of trees. So we have, in some cases, better air quality than cities of our size. But because we are obsessed with cars and everybody drives everywhere, and we have the largest public transit system in the country that is not supported by state funding, don't get me started, and therefore isn't very extensive, we have worse air pollution than certainly than we could. And what that means is that we have higher prevalences of asthma or kind of chronic respiratory illnesses, especially in our young populations, in our children. Now, why does that matter today? Well, it turns out that that is forcing us to redefine how we even think of a vulnerable population when it comes to something like COVID-19. We shouldn't have to worry about a 12, 13, 14-year-old otherwise healthy person getting a novel flu-like illness. But now, if that person has asthma, we have to be very concerned about much more serious complications, right? So the point is this: the point is not to be doom and gloom. It's not to be scary. The point is to say climate change is here. It is affecting our health, the health of our loved ones, our neighbors, our families, ourselves right now. This isn't something that we need to think about acting out of nobility for future generations anymore. It needs to be self-interest. It needs to be a kind of honest recognition that these are the stakes, right? So that's why carbon, but why climate change for the built environment? What is our connection there? Some of you may have seen some data like this, and especially if you were around last year, you're going to understand some of this. But to kind of level set, you'll hear that the built environment is responsible for almost 40% of global CO2 equivalent emissions every year. Now, 28% of global emissions come from building operations, and I want to highlight that this wedge here is actually only residential and commercial space. You'll see under industry, it has infrastructure, HVAC, lighting. Those are all obviously built environment inputs, right? But that's kind of a separate segment. So just our homes and our workplaces, 28% of emissions every year. But what's even more amazing to us, and where we in the specifying community and as manufacturers have a particular opportunity to influence and take action, is in this wedge that's 11%, the building materials and construction. This is what we call embodied carbon, and it means the carbon emissions associated with the supply chain, the creation of all the stuff that we actually use to build. So all of our furniture, all of our wallboard, all of our concrete, all of our steel, all of our flooring, any finish, anything, all of that stuff has to be made and costs carbon to create. So we have to really think about that and we have to grapple with that. But why would we focus on an 11% number if there's a 28% number out there, right? Well, first of all, the good news is we've spent a lot of time focusing on operational carbon emissions, right? So that the emissions that come from running our buildings. But here's why embodied carbon is so important. You know, abroad, especially in the UK, they use the term upfront carbon to describe embodied carbon. I actually think that that's a much more descriptive and intuitive term, because what it means is if you look at the carbon footprint of a single building over just 30 years, the embodied carbon of that building, that was all emitted before the building was even opened. So day one, before you've turned that building on, before you've run a single, mechanical system, before you've turned on a single light bulb, there's a carbon cost associated with that project. Now follow me here. Obviously, over time, operational carbon builds up. So if we look at our buildings, we want them to last for 80 or 100 years, maybe. Fantastic. Of course, most of the footprint that building contributes in terms of carbon emissions is going to come from the operational side of the equation because it builds over time. But what's really amazing is that upfront carbon piece, which again, 11% of global emissions for a single building, even over 30 years, is still going to make up about half of the footprint. So in other words, all of the good work that we've been doing, advocating for a more stringent building code, developing and then implementing high performance green building certifications, all that stuff is only dealing with half the problem over a 30-year time span. Which also means it's dealing with less than half the problem if you shrink that time span, you think about 5 years, 10 years, 15 years. These are the time horizons that we need to think very, very seriously about if we are going to make serious kind of action on climate a priority. All the best science is telling us that we need to peak our emissions within the next 5 to 7 years. And we need to be carbon neutral as a society, probably by 2040. And we're not going to hit that mark if we ignore the carbon emissions associated with making all the stuff with which we build, right? And when you consider the fact that projections from Architecture 2030 are that globally, we're going to build 2 trillion square feet of new construction by 2060. Put another way, that means the entire square footage of New York City every month for the next 40 years. If we don't think about the carbon emissions associated with all the material to make that possible, we're missing the boat. And it's going to happen so quickly that we have to take action now. So embodied carbon is really the urgent version of carbon emissions associated with the built environment. And this is what we call the time value of carbon. Climate change isn't waiting for us to completely electrify the grid. Climate change isn't waiting for us to insulate our buildings more efficiently. We have to think now, right, about the carbon costs associated with our actual construction. Another way to think about this, just from a rhetorical standpoint, is so we can kind of look at the proportions here as maybe a snapshot in time of the first 3 or 4 years of a building's life. But the other way to understand this is, look, the tip of the iceberg, meaning the stuff that we can see and that we understand, is that that operational carbon. And this is stuff that we directly control. It's comparatively really easy for us to get end users to act on, right? Because it helps save them money. This is literally just their utilities. But what's under the surface, what has a big impact that we don't understand nearly as well, we're not talking about nearly as much, is what we're calling specified emissions. Now, these are not directly controlled, but the good news is that you all in the specifying community have more influence over these emissions than any other community in the world, except for maybe manufacturers. So together, we can really, really make a difference on this. And that's where we need to go. Now, let's say you're on board. Great, I care about embodied carbon. Is it even possible? Is it even possible to find significant reductions? Great news. There's a lot of stuff that we can pick up off the ground right now. It's beyond low-hanging fruit that will make a big dent in the embodied carbon footprint of our projects. So this is a TI case study from a 10,000 square foot corporate space on the West Coast. And what the designer did is go through and just pick her kind of go-to specifications for each of these product categories. These are the things that she's comfortable with, the brands that she knows. Maybe it was her favorite rep. Maybe it's just, this is the stuff I know I can trust. But then she went back and said, okay, at no cost trade-off and at no performance trade-off, if I don't want to change the budget and I don't want to change my technical specs at all, can I find a lower embodied carbon alternative in the same category? And she found that just by paying attention in that way, she could get to a 43% reduction in the embodied carbon footprint of the project. Now, that's huge, right? That's big numbers. Which we think is really hopeful. So I hope that this serves as a signal that if you can find this data, then it will give you real big strides towards your kind of goals. And it's not something that we have to get really up in arms and excited about over a 5% reduction because your lighting is more efficient over a course of a year, right? As far as the rest of the kind of industry's response, I mentioned, high performance building certifications and building code being all focused on operational. That's traditionally certainly been true. But the good news is that LEED, for example, is starting to really take notice of this. And so in 4.1 in the BD&C manual, I guess, is a pilot credit for lower embodied carbon materials. And these are the categories that you can see on the left side of the screen there. I want you to note that you don't even have to reduce, you just have to measure. Just doing that benchmark will get you a point. And if you are able to measure a reduction of beyond 30%, then you get 2 points. Now, 30% sounds big, but remember, we just found 43% just by paying attention, not changing the budget at all. The other good news is I know obviously a lot of us, maybe all of us, are interior designers on this call. Their lead has committed, and if they haven't done it already, I think it'll be this month, to include a very similar version of this pilot credit in the IDCEC guidelines as well. Now, of course, the material scope is going to be slightly different because there's far less concrete and steel in terms of total material in TI projects. But some of the finishes will be the same, all that kind of thing. So it's the same kind of idea. Declare labels are also starting to report embodied carbon. And so as many of the manufacturers that have declare labels go through their renewal processes, which since Declare and ILFI made this commitment, which was last May, as in almost 18 months ago, the renewal process for the products that are kind of in the database now is really going to start in, I want to say, the next 6 months. And so you're going to start to see embodied carbon reported on Declare labels. Now, I think this is really crucial because Declare has become one of the most trusted labels when it comes to, the health of the materials in the built environment, especially for interior products. And that's great. It's really important to have this level of transparency. It's really important to have a good understanding of the level of toxicity that we're dealing with different material inputs. But we also have to measure how much of an input we are making to driving climate change, right? Because we know that has a big impact on public health as well. So hopefully this is another sign that the industry is moving in this direction. In a minute, I'm going to give you a demo of this tool, but this is actually kind of a spoiler. This is basically one of the major outputs of the Embodied Carbon and Construction Calculator tool. This is available for free at buildingtransparency.org, and really the high level of why this matters to you all is that this tool is making it so much easier than it ever has been to make specifying decisions, at least in part, based on the carbon footprint of the products that you're looking at. So whereas in the past, you might have to dig into an EPD, and you might have to learn enough about the life cycle assessment methodology to know where to find and how to read global warming potential numbers, which if it sounds intimidating, I think it is. I can't do it. This makes it a lot easier. Boils it down to a cradle to gate footprint and allows you to compare it across, okay? So I'm actually going to flip over now, although I wanna make sure, I don't think we have any questions or anything. Lauren, I'll let you interrupt me if there is something that we need to address sooner rather than later, okay?
We're all good for now, Joey.
Okay, thanks. So this is the EC3 tool. I'm actually going to start just by sharing a few of the resources that are just on like the homepage and stuff. So this is your homepage. Obviously in the first sentence, they didn't bury the lead like I did. Free and easy to use tool. It's going to remain free and easy to use. It was incubated at the Carbon Leadership Forum out of the University of Washington, but it now is housed by Building Transparency, which is a nonprofit. And I want to just stress that even just buildingtransparency.org has a lot of great resources on it. So if you go to Materials Can, for example, you can see there was a manufacturing series recently about manufacturers bringing their kind of expertise on a given product category and low embodied carbon materials within that category to kind of a public recording. So you can check those out. It has some information on that, has obviously some data on why this is important, which we just shared. So definitely check it out. Registration is super easy. You basically just have to put in an email, a password, and your name. So and log in. And then once you've logged into the tool, set up your account and logged in, this is your homepage. Now I have a little Zoom thing that I'm going to minimize here, because I wanted to point out, and I wanted to be able to see my own screen. Each page has this wonderful little thing called a tour. And if you click on this, it'll actually allow you to go through, it'll guide you through each page. and share with you kind of like where things are and what's going on. So even after this, if you still have questions, there are more resources in terms of demos and stuff, but it's also just great to be able to click around in there and you can kind of check stuff out for yourself. So there are two main features of the EC3 tool that I think you all are going to be interested in. Number one is find and compare materials, and then there's plan and compare buildings. We're going to start with find and compare materials. I'm going to start with finishes and carpet, because this is what I know the best. Sorry, everybody. And what you're going to first get is, after you've chosen the category that you want to look at, you're going to be asked to put in some performance specs. So the first decision that you have to make is whether it's tiles or broadloom. We're going to go tiles, and we're just going to pick a, let's pick an 18-ounce pile weight. You can specify yarn material. You can actually specify geography. If you go into advanced, you have even more options. You can just look at a specific manufacturer. You can actually search for a specific product, so you don't have to sift through a bunch of stuff, right? All good. Once you hit search, the first thing that comes up is this box plot diagram. What this box plot diagram shows you is there's a couple of really good elements of information on here. The CLF baseline, which is, I don't know if you all can read that, but this will, you can actually click on this and look at more details, but it actually gives you the number of the baseline for that product category. And what that is an estimate of the average for that product category based on all of the environmental product declaration data that has been pulled into the tool. So the way that this tool sources carbon footprint data is by taking environmental product declaration global warming potential numbers, which are a third-party verified, publicly available source of data, and basically bringing it into this tool so that it is a living database that you can compare much more easily than if you were to try to dig through EPDs and try to look at them either one by one or try to find some kind of comparability, because it can be pretty confusing to do that. The other thing is that the rest of the box plot is going to show you, based on the performance specs that you put in, here's the max within those specs. Here is where 60% of the data falls within that category for those specs. And then here's the lowest possible thing in that realm, right? So if we look at this, you're going to start to see the way that it is organized out. You're going to have manufacturers. You're going to have the place that it was actually manufactured. You're going to have the kind of product name, which is typically something a bit wonky because it's kind of like the, the backing or the yarn system combination. It's going to give you the pile height that you asked for. It'll even give you the yarn material. And then, of course, it'll actually give you the embodied carbon per square foot. And you can organize just like an Excel spreadsheet for any of these things and see them just in that order. You can also compare specific products. So now what we're looking at is each manufacturer. Again, this is that box plot we just saw. This is the box plot for Troup County, which is interfaces EPDs. And then these are, so these are kind of fuzzier dots because they're still working through some of that EPD data to kind of make sure that it's consolidated, consistent, finalized, that kind of thing. But for each of the manufacturers, you could also even just compare one from each so that you can kind of see it a bit more easily in that way. It'll give you the relationship to where it is based on the technical specs that you make. All right. Now you can do this for any of the product categories in here. And I'm sure one of the questions that we're going to get, which is totally appropriate, is, well, okay, so I specify a lot more things than just those first product categories. So when are we getting more data into the tool? Great question. Totally fair. It's on the way. There are, I think, 6 or 7 pilot categories that are already loaded in or being loaded in that should launch pretty soon. One of the 2 that I know are coming out soon are actually cabling. So communications cable and wiring, which if you're doing interior products can actually have a surprisingly significant impact on your carbon footprint there because it's all metals. And then resilient flooring as well. excuse me. But resilient flooring is obviously a pretty complicated category. There's a lot of different ways that you could go. I do want to make a quick note on concrete. Concrete contributes 6% of global CO2 emissions from human sources every year. Concrete alone, meaning the manufacturing of it, the raw material collection, the processing, and then the curing on site. All of those things actually have carbon impacts. And that means that it is an incredibly important material for us to manage. So if you're working on new construction projects, please think about whether you can find a lower embodied carbon material or lower embodied carbon version of concrete, which is out there. This tool has over 25,000 EPDs for concrete specifically already loaded into it. So there's a lot of data out there. But again, it's the same principle as that carpet. So you put in your technical specs and you can compare by geography. The reason there are so many EPDs in there, for the record, is that the concrete industry actually publishes EPDs for mix specific and plant specific products. So which has an impact on the carbon cost. So anyway, so it's actually a really good tool for that. Let's talk about the next section. This is plan and compare buildings. So you'll first see you have my buildings. This is actually where you can load in your projects. And what that's going to look like is I'm going to go to public and I'm going to search actually just a TI project. So there's like a sample TI project in here. And once you have specified particular products, you can load them into a full building project like this, and you're going to get a screen that looks like this. So it's going to give you some of the basic stuff that you've loaded in about your project. It's going to give you the specific products that you have chosen and kind of their material, where they fit. But here's what I wanted to show you. If you go to View GWP Summary, you're going to get this. This is what's called a Sankey diagram, and it is looking at each of the product categories that you've made a material choice in, and it is showing you the baseline for that product category, the baseline for everything added up as though it's for the full project. Your specification is the line that's at the very bottom of the hashed area. And what this tool also allows you to do is establish a target reduction for your entire project. So again, if you wanted that lead credit, you could say, I want my target to be 35% so that I'm safe. And you can track how each of the specification choices that you've made is going to contribute to that reduction. So what you'll get here at the end is adding up all of the specifications from the product category. The bottom of your hatched line is, well, actually, as it turns out, I've reduced 78% from the baseline, and my target was only 68%. So I'm good, and that's really cool, right? You can see, obviously, this includes insulation, which does have a huge, it has a big range of carbon intensity, basically, based on the different materials that are in use there. But it allows you to kind of track your progress. And again, this would be a great way for you to learn about embodied carbon in the products that you're choosing, look at the difference between certain materials, and even achieve that lead credit point that we were looking at before. Okay, so I'm gonna pause there. I have like one more slide here, so let me just knock this out. If you're interested in really diving in and learning more about this, I showed you all on the building transparency, the information that they had on Materials Carbon Action Network. That is also its own website, materialscan.org. Great place to learn about embodied carbon in the product categories that are represented by the founding members there, why embodied carbon is important, carbon offset guidance as well, which once you start to ask your manufacturing reps, hey, are you willing to sell this to me carbon neutral? And they'll go, well, what do you mean? And you go, well, carbon offsets. And you go, well, what do you mean? And you go, well, here, buy some of these. And then the other thing is the new carbon architecture, which is basically Project Drawdown, if you're familiar with that book, which you met Catherine Wilkinson earlier yesterday. She was the kind of principal writer on that project. And that as kind of solutions for reversing global warming across the world, the new carbon architecture is essentially that approach, but for the built environment. So it's for architects or designers. Bruce King wrote that. The first chapter is all about embodied carbon, and the rest of the book is about different either carbon negative or low embodied carbon materials and how they can be integrated into design and architecture. So really good resource there as well. All right, I'm gonna stop sharing, come back to the talking heads so that hopefully Lauren will join me and I won't be screaming into the void anymore. And I see a couple of bubbles, so I'm gonna check on chats and Q&A with Lauren as well.
Okay. Yeah, so first question, approximately how many manufacturers are included in the tool at the moment and how are they growing that number?
Oh gosh, I don't know. I don't know what the number of manufacturers is. I would say for obviously carpet tile, where I'm most familiar, every major manufacturer is included because EPDs have become a fairly common element of transparency documentation for our category. Concrete as well, clearly it's such a popular approach. I would imagine that most, if not all of your major concrete manufacturers are in there. And they might even be in there with like local data, meaning like the plant that's closest to your project. But how we're growing it, I think honestly, materials can, right? That community and building transparency, the board of that nonprofit are continuing to kind of spread the word. We want to get more designers on board. We want to get more people asking questions about embodied carbon, asking questions of their manufacturing reps, right? So that they learn about the tool. And to be honest, it's free and super easy to get involved. You can load EPDs into the tool from any source. Like you could do it yourself. And then the kind of tech team in the back looks at them, makes sure they're not already in there, make sure that they're of the right PCR, all that kind of thing, and adds them to the database. So it is basically open source, and we hope that it grows to new heights every other week or moment by moment.
Cool. What's your recommendation for alternative materials to concrete since other materials also have carbon?
So this is where I get to go, well, I'm not a designer, so I don't really have a good answer for that. I would say this, like I think it's unlikely that concrete is going away anytime soon. That does not mean that we can't do anything. That means that we need to think very hard about what concrete we're buying, and we need to have as much transparency as possible about that mix and that specific mix and its impact. And that is doable thanks to EC3. There's a lot of discussion, and I don't know if we've gotten to it in the content over the last couple of days. Maybe Lauren, you can kind of course correct me here, but there's a lot of talk about things like mass timber. There's some talk about things like hempcrete even. I am personally kind of the belief that bio-based materials like those are going to be important, but I think it's a big time open question about whether we can produce those at scale to meet our appetite for building. So what I might imagine is that we are going to have to find a compromise or a combination of kind of synthetic, human-made materials and bio-based materials that will help us with the carbon story. Because, even just if you think about mass timber, right now, where it is most popular is Canada. Makes a lot of sense. There's a lot of trees. There's a lot of managed forest. We have similar capacity maybe in the Southeast because we got a lot of trees. What about Arizona? And like, are we able to produce wood, to grow wood in forests in the northern climes of the world to serve the entire kind of like, from the equator north, and then do the same with with rainforest type material, so I think it gets a little complicated, and I'm a big fan of using mass timber, and I want to see it more, and I think there should be no policy barriers to it, to be honest with you. But I don't know that that's going to like kind of save us. So I think it's the same thing where if you ask about concrete or you ask about any particular structural material, because the other big one is steel, by the way. That's the other kind of biggest impact material. It is an open question about whether bio-based alternatives will meet that entire demand. And but we can't figure it out if we don't ask the question. So I really appreciate the question. I'm sorry I don't have a silver bullet for you.
Well, no, I think that is the answer, is to continue to ask the question, make sure the conversation is happening and that you're part of it. Let's see, we've got one more. What would the impact difference be between something with less than 1 versus the acceptable range of 3 or so that was listed as the CLF baseline for carpet?
Okay. I think I understand this question. Jen, please correct me if you're like, that's not what I was asking. So if we look at any of these individual product categories, the raw number that is the baseline versus the specific product that you've chosen probably matters less than the difference, proportionally and kind of linearly. So it is impossible for me to say, per square foot of carpet, if you're putting 1/5 of 1 kilogram of CO2 into the air, you're making 3 more kids cough, like as opposed to 2 kilograms, you're making 10 kids cough. That's not really how it works. It's obviously not that direct. So when you ask about the difference between the impact of a low carbon option versus a higher carbon option, you have to really think about the aggregate, not just for that product category, but for the entire project. And that's why it's crucial to look at the kind of hotspots, material by material, that are going to have the biggest impact on your project. So for an interior project, carpet turns out can be one of your top 3 most carbon intensive product choices because of the presence of nylon yarn. So nylon, because it's super high performance plastic and it takes a lot of energy to create, is going to drive the carbon footprint of a carpet tile, period. If you use nylon, it's going to be the most carbon intensive product in there, material in there. So the number one thing that you can do is specify recycled nylon to help offset or reduce that impact, the highest impact part of one of the highest impact materials in your interior project. Where I hope the industry is going, and this is kind of the moonshot, right, is to not say we're competing for who can do the least damage. We're competing based on who can be the most efficient, but rather we're competing to see who can provide you with all the things that you need: performance, aesthetic flexibility, beauty, durability, quick ship times, whatever, and also store carbon. So go from creating a built environment that 11% of our global human-caused CO2 emissions every year, or CO2 equivalent emissions every year, come from building materials, actually turn that into a carbon sink. So our built environment becomes a place where humans have industrialized the process of storing carbon, taking it out of the atmosphere, putting it into a solid, safe state, interrupting those molecules, taking them out of the carbon cycle, so that we actually help to reverse the damage that we've been doing for the last 150 years. And to get there, we have to start with the lowest footprint possible, and then we have to think about, in the same way that we're doing hotspot analysis of given materials in a project, we have to do hotspot analysis of given material inputs in a product and turn those into the lowest footprint materials as we can, and then actually carbon storing bio-based materials that we can. And when you think about that level of innovation, you open up a supply chain that is not just how do we use trees to make buildings, but actually how do we use any formerly living photosynthetic organism that maybe would otherwise be a waste product. So if you think about agriculture, we don't harvest the entire product that we grow or the entire plant that we grow. We look at corn, we take the corn out, and then we have these massive stalks that are doing nothing, right? So it's that type of material that if we can figure out a way to integrate into the built environment as part of the material inputs, then all of a sudden humans are becoming we're kind of paving the way to become a carbon sink. I hope that wasn't either too all over the place or too like out in left field, but I think that's the important question is not what's the difference in impact between one of the low one versus one of the high one. The important question is kind of what's the value of going in that direction.
Yes. Jen confirmed that you did indeed answer.
Okay.
That was about 4 minutes ago, though.
Yeah. Well,
I'm kidding.
Actually, I have one other thing that's occurred to me to share, Lauren.
Yeah, go ahead.
I know we had another question or two, but there is a qualitative resource that I want to share with this group as well. And it is the Carbon Smart Materials palette. So let me come over here, and it's a very simple URL, materialspalette.org. And what this allows you to do is instead of looking at the quantitative impact of specific products in a category, you can actually get, there's good background information on here. If you go to the palette itself, you're going to see directionally what are high impact materials, what are carbon smart alternatives, right? And then even some information on approaches to whole building emissions reductions. Now, look, are we all going to turn around and start specifying exclusively sheep's wool as insulation? Probably not, right? But the idea here is with carbon smart materials, what you're able to do, and we can look at concrete as an example, is understand why this material has a certain level of impact. Why is it a high impact material or why is it a low impact material? And then, kind of a take home message, right? Using less cement is the most effective way to reduce carbon footprint of concrete because concrete is essentially an aggregate and cement. Cement is basically melted rock. This is the thing that takes so much energy to create, right? So if we can specify lower cement mixes, then we're making a big impact on the carbon, right? And this is where you can kind of get directionally accurate information about various different materials without having to dive in again to EPDs or like become a life cycle assessment expert. Mm-hmm. So I don't necessarily need to spend a ton of time on this. And to be honest, again, I'm not a designer and I kind of try to stay mostly in my lane because I feel like I still have a lot to keep up with just in flooring. But there are a lot of kind of good materials to check out and research here. And again, free kind of open source tool.
Yeah, no, that's great. That's just one more tool for the toolkit, right? Thank you for sharing that. We'll drop that link in the chat function for everybody. I have one more question for you, and that is, this year has been a tough one, and we've seen the magnification of good and bad through this environment we're living in. I wonder what's inspiring you, what leaves you hopeful in this time?
The kids. So honestly, I think that the youth climate movement is a watershed moment in human history. And I think that we are witnessing the continuation of a consciousness that was at first ascribed to, a millennial generation that has been written about in an unbelievable amount. But now young leaders are even less apologetic. They're even less compromising about what needs to be done. And even though that can be abrasive and sometimes it can come off as naive, the reality is it's science-based decision making. It's data focused, approaches to problem solving. They're like, no, we don't actually necessarily know how to get there, but we know that this is where we need to go. And we are going to hold the solution builders accountable to that as a standard rather than, oh, thank you so much for making progress. Right? Or, oh, would you please make some progress? Which is like the best that even my generation has really done. And I'm about 30. So I think about the 15-year-olds, the 17-year-olds who are combining online engagement, political activism, identity reconciliation, and climate action. And I think, that is literally the future because they are going to grow up, but it is also kind of ideologically, I think, the future. Mm. And all we can save is chronicling a snapshot in a movement that is multi-generational, but is certainly, as comprehensive as it is going to look like much more the norm about in terms of how we talk about these issues, who we talk about them with, what the solutions that we try to build are for this next generation of climate activists, and hopefully the next generation of designers, and hopefully the next generation of building owners and commercial real estate professionals and politicians and teachers, all of it, because I do really feel that with the ubiquity of information and the clarity of purpose that so many young people are uncovering, that will become the norm and not the exception. That will become the rule. And to be honest, that's exactly what we need. So I find hope in that.
That's wonderful. Thank you for sharing.
Sure.
I think if we can keep our eye on that and continue to be part of the conversation, it is a very exciting time to be part of it. And this group that we're sort of talking to today, they can hear us, they can see us, is a big part of that, in my opinion. And it's really exciting to bring you and all this information into the conversation. So thanks, Joe.
I think it absolutely. I'm happy to be here. I think it's crucial that the design community. I do not want you to feel blamed. Nobody's been doing anything right for 150 years, but I do want you to feel like you have more of an opportunity in your professional life to kind of take action on climate than in the aggregate of any personal decision that you could ever make. You could give up your car, eat vegan, and live in a mud hut from now until you die and still not be responsible for averting as many emissions as if you make a significant change to the type of concrete that your firm just goes to and specifies, right? That's a big deal. And I want people to feel some level of hope and kind of joy with that, because I want you to see it as an opportunity. I want you to be excited about that. I don't want you to be intimidated by it or scared by it, because we need it all. So you don't have to do exactly the right thing. You don't have to do the best possible thing. You don't have to do everything. But if you do something, then we're going in the right direction.
I completely agree.